Welcome students. In the previous lecture, we have seen the information about amines, their preparations and their reactions. Students, we are proceeding further. Now the second part is diazonium salts. We are going to see in detail what are diazonium salts, what is benzene diazonium chloride, the reactions of benzene diazonium chloride, and finally synthesis of methyl orange and Congo red dye. Now students, the diazonium compounds obtained by the reaction between primary aromatic amines and nitrous acid at 0 degree temperature, ice temperature, and they are called as salts. And the process of formation of these salts is known as diazotization. Di means 2, azo means nitrogen. The compound having 2 nitrogen atoms are known as diazo compounds. Okay, the term azo comes from the French word azote meaning nitrogen, and ammonium comes from ammonium, that is compounds resemble ammonium salts. Okay, these are the compounds. They contain N2Cl group, that is N plus triple bond N with X as an anion, that is X minus, and that X minus may be Cl minus, Br minus, NO2 minus, HSO4 minus, BF3 minus, which is attached to aryl unit, and it is called as diazonium salts. First one is benzene diazonium ion, and when it is converted into benzene diazonium chloride, this is a benzene and this is a diazonium chloride. Okay. Now students, these salts are important in the industrial processes. They are used in the industry for the manufacture of azo dyes, in the drug industries, and several aromatic compounds. They are comparable with Grignard's reagent in versatility. Now, how the diazonium salts are nomenclated? They are named by adding the word diazonium to the name of aromatic compound, and it is followed by the name anion. For example, this is a benzene compound. Benzene, this is a diazonium chloride, therefore name benzene diazonium chloride. Second one is benzene diazonium bromide. Third one, benzene diazonium hydrogen sulfate. Here at para position methyl group, therefore it is a methyl benzene, that is para-toluene diazonium hydrogen sulfate. Last one is para-nitrobenzene diazonium fluoroborate. Thus, they are named by adding diazonium and followed by anion. Now we are going to see compound benzene diazonium chloride. This is the structure having the molecular formula C6H5N2Cl, as it is a salt, therefore it returns as N2 plus Cl minus. The first one is Bronsted formula. The second one is Kekulé structure. Okay. Now how benzene diazonium chloride is prepared? Therefore, the procedure is dissolve 2 gram of aniline in 10 ml of dilute hydrochloric acid, and which is taken in a small flask. Then second step, dissolve 2 grams of sodium nitrite in 10 ml of water in the another flask. Okay, there are 2 flasks taken. Then cool the both flasks in ice bath to attain the temperature below 278 Kelvin. That is a 0 degree. Therefore, they are prepared at ice temperature. Now keep the aniline flask, that is the first flask, in ice bath throughout the reaction, and then add the solution from the second flask, that is solution of sodium nitrite, slowly and gradually with constant stirring to the aniline flask. Of course, the reaction is carried out in ice bath. Yes, this is the reaction. As nitrous acid HNO2 is unstable compound, it is generated in the presence of aromatic primary amine by the reaction between sodium nitrite or amyl nitrite and mineral acids like hydrochloric acid. That is, it is a prepared, nitrous acid is prepared in situ. Now the reactions are, the first reaction, sodium nitrite treated with hydrochloric acid, formation of, this is sodium nitrite treated with hydrochloric acid, formation of nitrous acid in the reaction with elimination of sodium chloride. Now when aniline is reacted with hydrochloric acid, aniline hydrochloride salt is obtained. Now in the last, this aniline hydrochloride salt reacts with nitrous acid. Of course, the temperature is 273 Kelvin to 278 Kelvin, and thus benzene diazonium chloride salt is obtained, and this is the preparation of benzene diazonium chloride. Now the properties of benzene diazonium chloride, physical properties: it is a colorless crystalline solid, readily soluble in water but less soluble in organic solvents like alcohol ethers. Of course, it turns brown when it is exposed to the air. Therefore, it should be kept tightly. It is harmless in aqueous solution but dangerously explosive in dry state, and therefore it is used as an aqueous solution. Aqueous solution is a neutral and it conducts electric current, and this shows that the salt has salt-like character. Chemical properties of benzene diazonium chloride: it is a highly reactive compound and shows the reactions like replacement reaction, in which the diazonium chloride group, that is N2Cl group, is replaced by other monovalent group with the liberation of nitrogen. And second type of reactions are reactions in which the two nitrogen atoms are retained, that is not removed. Now we are going to see the first type of reaction where N2Cl group is replaced by another group or atom. The first reaction is replacement by halogen and cyanide group. The reaction is known as Sandmeyer's reaction. Here, benzene diazonium chloride is treated with cuprous chloride or cuprous bromide and with cuprous cyanide in the presence of their corresponding acids to give chlorobenzene if cuprous chloride is used, bromobenzene, cuprous bromide is used, or benzonitrile when cuprous cyanide is used. Now, the reaction is carried out in the presence of their corresponding acids. Look here, this is a benzene diazonium chloride. When cuprous chloride is used, the corresponding hydrochloric acid is used, and the temperature, of course, 298. Chlorobenzene is formed, N2 is released, and therefore the reaction is replacement of N2Cl group. Second one is benzene diazonium chloride on reaction with cuprous bromide. The corresponding acid is hydrochloric acid, that HBr, and here N2 is released, forming bromobenzene. In cyanide, when cuprous cyanide is used, benzene diazonium chloride on reaction with cuprous cyanide with presence of corresponding acid KCN, the cyanide compound, that is also known as nitriles, and therefore the product is benzonitrile, and the reaction is of the type replacement of N2Cl group. The nitrogen is evolved in these reactions. Another reaction is replacement by hydrogen atom. Here the benzene is formed. Benzene diazonium chloride reacts with hypophosphorus acid. This is the benzene diazonium chloride, hypophosphorus acid in the presence of cuprous ion. Formation of this is a benzene. Benzene is formed. Okay, and this is the important reaction for the preparation of benzene, and therefore benzene diazonium chlorides are very useful in the preparation of other important compounds. Now, replacement by iodine atom. Here, benzene diazonium chloride is treated with aqueous potassium iodide. The product is iodobenzene. Here, benzene diazonium chloride reaction with Ki forming iodobenzene. Again, the variety is replacement releasing nitrogen atom. Replacement by OH group, that is phenol, is formed when aqueous solution of the salt is slowly added to dilute and boiling sulfuric acid. The diazonium group is replaced by hydroxyl group, and thus phenol is formed. This is the reaction benzene diazonium chloride in presence of sulfuric acid. This is hydroxybenzene, that is a phenol, with the elimination of N2. And therefore, all these reactions are those in which N2Cl group is replaced. Now, another variety, the reactions in which the two nitrogen atoms are retained, that is maintained. The first one is reduction of BDC to aryl hydrazines. Now these aryl hydrazines are synthesized by reducing BDC, that is benzene diazonium salt, with sodium sulfite or stannous chloride SnCl2, followed by acidification with hydrochloric acid. This hydrochloride derivative crystallizes out on cooling, which is decomposed by alkali sodium hydroxide to liberate free hydrazine derivative. The first reaction, sodium sulfite, here, okay, is converted to sodium sulfate. Now this benzene diazonium chloride is reduced to phenyl hydrazine. Here the two nitrogens are retained. Now another important reaction of benzene diazonium chloride is coupling reactions. Aromatic compounds like phenols, naphthals, amines react with benzene diazonium chloride to form the compounds of the type AR dash N dash N dash AR. Okay. These compounds are known as azo compounds, and the reaction is called as coupling reaction, that is they are coupled. Here in azo compounds, the diazo group acts as the bridge between two aromatic rings. Now in these reactions, nitrogen atoms of benzene diazonium chloride are retained and they are converted into more stable grouping. Now of course, these coupling reactions are carried out at 273 to 278 Kelvin temperature. Okay, the first reaction is synthesis of methyl orange. The reaction is of the variety of coupling reaction of benzene diazonium chloride. The steps involved in the synthesis of methyl orange are, the first one is formation of diazonium salts. Now para-aminobenzene sulfonic acid on diazotization gives diazonium salt. This is para-aminobenzene sulfonic acid on diazotization NaNO2HCl at 273 Kelvin temperature. The formation of diazonium salt takes place. Now this is used for further. This diazonium salt is used, it is coupled, this diazonium salt is coupled with N,N-dimethyl aniline. Therefore, coupling with N,N-dimethyl aniline, methyl orange is formed. This is the formation of methyl. This is a HCl is removed and N double bond N. This is the first unit coupled with the second unit, and this is the reaction of coupling reaction, the formation of methyl orange. Okay, this is the para NN dimethyl amino azo benzene sulfonic acid. It is used as a indicator. Second one is synthesis of Congo red. It is prepared by using benzidine and naphthenic acid. The steps involved, the first one is formation of tetraazotized benzidine. Starting material is benzidine, on diazotization gives tetraazotized benzidine. This is a benzidine. Diazotization, tetraazotized. Okay, this is a tetraazotized. Tetraazo. These are two, therefore tetra, 4, and therefore it is a tetraazotized benzidine. In the second step, this tetraazotized benzidine on coupling with two molecules of naphthenic acid, Congo red is formed. This is the acid, one molecule. This is our tetraazotized benzidine obtained in the first step. This is the second molecule of acid. Coupling takes place and Congo red dye is formed. Okay, this is the Congo red. Therefore, we have seen two synthesis. The first one was synthesis of methyl orange, and the second one was synthesis of Congo red. Okay. Now, uses of Congo red. It is a red alkaline solution. Its sodium salt dyes cotton fiber directly. That is used as a dye. Of course, this dye is sensitive to acids and it changes the color from red to blue in the presence of acid, inorganic acids like HCl. Okay, and therefore it is sensitive to acids. And of course, the use of methyl orange as an indicator, we are knowing this. Thus, we have seen the diazonium salts, their preparation of a benzene diazonium chloride salt, and the coupling reactions of benzene diazonium salts along with the reactions of elimination of N2Cl group and retention of N2Cl group. Finally, these two dyes are important. Thus, we have completed this topic, amines and diazonium salts. Students, here I conclude my lecture. Thank you.